All right, this is our geometry video for the assignment for this week, which is the week of January 4th, our remote learning week. So make sure, like I said yesterday, that you are copying down the problems that I do here in these notes as well as answering them, because I know you don't have these worksheets in front of you. So copy the problem, write your answer, and then I will post the video along with a picture of some homework problems for you to do. So this is your reminder to turn your sound up so that you can hear everything I'm saying about our problems. Now, like I mentioned yesterday, this is going to be a review of all the types of problems we've done in our trigonometry unit. So what I did is I took the unit study guide and I picked a few problems from each section that we did, and I'm going to go through those with you. So you do not have to copy down everything that's on here because this is a really long study guide and we're just going to do some of them. So again, if you need to pause or rewind or anything, this is your video once it's posted to watch at your pace. Just remember to copy down what you see in front of you and then answer it, because if you just write down the answers to these, they're probably not going to make much sense later when you're trying to do your homework. So for example, what we started with and this is our unit 4, not unit 8, but what we started with was the Pythagorean theorem. So this applies to right triangles, and our Pythagorean theorem is a squared plus b squared equals c squared, where a and b are legs and c is the hypotenuse. Now a and b, if you remember, are interchangeable. It doesn't matter which leg you call a and which leg you call b, as long as the side across from your right angle is always your hypotenuse. Okay, so the hypotenuse is always going to be c. Now what we're asked to do is solve for x. So we've got this variable here, and it just happens to be across from the right angle, so we are solving for c. Now our legs are 9 and 17. So that is 9 squared plus 17 squared equals c squared. Okay, so we're going to solve for c, and then we're going to round our answer to the nearest tenth. So if we square both of those numbers, we get 81 plus 289 equals c squared. We're going to add these up and get 370. And then we almost have c by itself. The last thing we have to get rid of is this little exponent of 2. And the way that we do that is we do the inverse of squaring, which is square root. Okay, so we're going to take the square root of 370. Now, one thing we did after our Pythagorean theorem problems is we talked about simplifying radicals. So instead of getting a decimal approximation, we want to check to see if we can simplify the number under the square root by using our perfect squares. So these numbers here are all of our perfect squares for numbers 1 through 30. Okay, so we want to see if any of these numbers can go into 370. And actually, none of them can. So unfortunately, we're going to have to leave this answer just as the square root of 370 because we can't simplify it any further. Okay, so the one next to it, again, we're solving for x, but our hypotenuse is given to us, which is 14. So we are solving for one of the legs, and I'm going to call that leg A. So I'll call this A. I'll call that side B. Okay, your legs are the two sides that make up your right angle. All right, so we have a squared plus 11 squared. Here's our other leg. And our hypotenuse this time, we're not going to write c, we're going to write 14. Okay, so if we square both of these numbers, we get 121 and 196. So remember, if you want to square a number in your calculator, just use this x squared button. Type in the number, press this x squared, and it will do the math for you. Okay, so we're solving for whatever letter A, B, or C that's in the problem. So we want to get everything away from what we're solving for. So in algebra, you always do the opposite to move something away from your variable. So a squared ends up being 196 minus 121, which is 75. Okay, now what we need to do is the inverse of squaring, which is square root. So we're going to take the square root of 75, but remember, we can simplify this and get a more approximate answer. So what we want to do is see which of our perfect squares, what's the biggest perfect square that can go into 75. So looking here, obviously I'm not going to get 81 in there. I'm not going to get 64 or 49 or 36, but I can get 25 in there. So if I simplify, and I'm not going to do this problem down here, so I'm going to split this into the square root of 25. Now, how many times does 25 go into 75? Well, it goes in 3 times. So I'm going to split this into 25 and 3, which are my factors that I'm going to use for 75. Now, 25 is a perfect square, so we can take this square root and get 5. 3 is a prime number. It's not a perfect square. I can't get a square root for it, so I'm going to leave it as the square root of 3. Okay, so the leg that we solved for, the A, is actually 5 times the square root of 3. And that we got from simplifying the square root of 75. Okay, so these are our Pythagorean theorem problems that we're going to do. Now I'm going to move on to what it says is topic 2, and that is the converse of the Pythagorean theorem. So like the flip side of what we can do is we can classify triangles as right, acute, or obtuse. So the way that you do that is you kind of turn the Pythagorean theorem around. All right, we're going to start by writing c squared, okay? If it's a right triangle, then it's just the Pythagorean theorem that we used above. A squared plus b squared equals c squared. If it's going to be an acute triangle, then c squared is going to be less than a squared plus b squared. If it's an obtuse triangle, then c squared is going to be greater than a squared plus b squared. So all we're doing in these two types of problems is we're checking to see what kind of triangle we have if it truly is a triangle. So this note off to the side says, remember, to be a triangle, the sum of the 2 smaller sides must be bigger than the third largest side. So that's the first thing we want to check is, do we even have a triangle to bother with this math? So let's look down here. Here's the length of our 3 sides. So the longest is 29. Okay, so we're going to see, does the 2 smaller sides, if we add them up, do we get a number bigger than 29? Yes. 20 plus 21 is 41. That is definitely bigger than 29. So let's see what kind of triangle we have, because this is not going to be one of our answers. So I'm going to take c squared, longest side is the hypotenuse. We're going to see how that compares to 20 squared plus 21 squared. Okay, this gives me 841. And if I square these and add them up, I get 841. So if they equal each other, then it ends up being a right triangle. So I'm going to circle that answer. Okay, so when you're copying these problems down, just put some directions and make sure you include the numbers. So classifying the triangle, the side lengths are 20, 21, and 29. So make sure you definitely have the information from the problem before you start writing your answer. Okay, over here, our longest side is 10. Okay, is 5 plus 9 greater than 10? Yes, because this is 14. So we know we have a true triangle. Let's just see what kind. So the longest side is your hypotenuse, so that is c squared. Let's see how that compares to a squared plus b squared. Well, I get 100 by doing this, and then I get 106 by taking 5 squared plus 9 squared. So c squared is less than a squared plus b squared, which means we have an acute triangle. Okay, so make sure you write acute for this answer. And then I'm going to take my page, I'm going to flip it because there's 2 more that I want to do with you before we move on to our special right triangles. And that's these 2 problems right here. So let's double check. Longest side is 3 plus 15 bigger than our hypotenuse? No. So really, we can stop here because this is not a triangle. The 2 shorter sides have to add up to a sum that's greater than your third longest side, and that does not. So moving on to this, here's our hypotenuse, 28. Is 16 plus 21 greater than 28? Yes, because it's 37. So we know we do have a triangle. Let's just see what kind. Our hypotenuse, the longest side is 28. Let's see how that compares to a squared plus b squared. Okay, if I take 28 squared, 784. My phone keeps adjusting the focus. Let me try to move closer. 16 squared plus 21 squared is 697. So our c squared is greater than a squared plus b squared, which means this triangle would be obtuse. Okay, moving on to, let's see, our second to last topic. This one's a little bit tricky because these are our special right triangles. So our special right triangles are the 45, 45, 90 degree triangle and the 30, 60, 90. So that means the three angles within that right triangle are the following degrees. Now we're gonna label the sides. So this is good to have in our notes. I want you to draw these two right triangles, label them with their degrees. Obviously these right angles are 90. And we're gonna put what these sides represent in each of these kinds of triangles. So every single time you have a 45, 45, 90 triangle, your two legs, okay, so across from the 45 degree angles, those are just going to be called x. Now your hypotenuse, which is across from the right angle, that is going to be x times the square root of 2. So you have these in your notes from when I was out in December. So if you do need to double check more problems, you have notes on these if you have your math binders at home. But this is just going to be, like I said, extra practice so we can recap. Now in a 30, 60, 90 triangle, you have two legs, but you have a shorter leg and a longer leg. All right, so the shorter leg is across from the 30 degree angle. So the shorter leg is represented by x. The longer leg, which is across from the 60 degrees, is x times the square root of 3, which leaves our hypotenuse across from the right angle. Over here, it's the slanted side across. This is represented by 2x, okay? So you have two congruent legs in this triangle. You have two different length legs in this type of triangle. So let's use these rules to find the value of each variable, x and y. So our first problem that we're going to do, I'm going to do these 5 that I circled, okay? And you can number them however you want on your paper, but I have a 45, 45, 90 triangle. So that means if here is a 90 degree angle, then that means this angle must also be 45 degrees. So in this type of triangle, your two legs are congruent. So if this leg is 5, then that leg is 5. Okay, now y is our hypotenuse. And the hypotenuse in a 45, 45, 90 triangle is your leg times the square root of 2. Our leg is 5, so I'm gonna put that 5 times the square root of 2. And that one's done. Our next triangle is the 30, 60, 90, because I see a 30 here. This is a 90, so this must be our 60 degree angle. Okay, so across from your 30 and your 60, those are your two legs. So this is going to be your shorter leg where the 9 is, and this side is going to be your longer leg. Okay, so we're going to use these 3 rules up here to figure out what x and y are. Now, if I'm trying to find, let's do x first. Okay, x is going to be my hypotenuse. Now the hypotenuse in a 30, 60, 90 triangle is just 2 times the shorter leg, okay? Well, my shorter leg is 9, so what's 2 times 9? 18. Now, y is right here along this side, which is the longer leg. The longer leg is x times the square root of 3, or the shorter leg times the square root of 3. So I'm gonna look over here. Again, my shorter leg is 9. So I'm just gonna take that 9, put it multiplied by the square root of 3, and that one's done. Okay, third one here, we have a 30, 60, 90. I'm just gonna put that 30 in there so I can see it because the 60 is already here. So across from the 60 degree angle, that is your longer leg. Across from the 30 degree angle, That's your shorter leg. And then of course that leaves your hypotenuse. Okay, so I'm just labeling sides there. Now let's see what we got. We got to solve for x, which is the longer leg of a 30, 60, 90 triangle. So that is going to be your shorter leg times the square root of 3. Well, we don't know what our shorter leg is right now. Our shorter leg is just y. So let's start there. Our shorter leg is just represented by x, okay? Our hypotenuse is twice, 2 times the size of the shorter leg, okay? Well, if our hypotenuse is given to us as 22, then that means this hypotenuse is twice whatever the shorter leg is. Well, 22 is twice the size of 11. So that means 11 times 2 gives us our hypotenuse. So the shorter leg must be 11. We're gonna split 22 in half. The only thing you can get is 11. So we have this now. Let's find x again, which is gonna be our longer leg. So the longer leg is the shorter leg times the square root of 3. Well, now that we have our shorter leg, which is 11, we're just gonna put that in front of the square root of 3, okay? So let's do these last two because we've got a little bit of solving in this, and I think the video that you guys watched before Christmas break when we did these notes, it had problems like this where you had to do a little bit of solving. So these are gonna be one of each, 45, 45, 90, and then we have a 30, 60, 90. Okay, so I'm just gonna label those. Now, we have to solve for x and y again. Let's look at this 45, 45, 90 triangle. I know that the hypotenuse is 16, okay, and that my 2 legs are going to be congruent. Okay, they're both going to be represented by x, and the hypotenuse is x times the square root of 2. Now, one thing I mentioned in the video for your last set of notes is don't get these variables confused with the variables in the notes, okay? This x and y could be any letter. It could be a B, it could be a Q, it could be a T, anything. They just chose x and y. It's not the same as this x though. Okay, so we're gonna have to do a little solving. Now, if we know that our hypotenuse is 16, well, the hypotenuse is equivalent to the leg times the square root of 2. So I'm gonna solve by saying 16 is equal to x times the square root of 2. That's what the rule tells us. So if I want to find out what x is, I'm really finding out what the leg is, okay? The 2 congruent legs are represented by the letter x. I'm going to solve for it. So to solve for something, you want to get that x by itself, which means you want to move everything away from the letter x. So I'm going to divide by the square root of 2 because it's the opposite of multiplying. Now, we can't have a radical, a square root symbol in a denominator. So how do we get rid of a square root symbol in our denominator? Well, I'm going to rewrite this, and you do the inverse. So the opposite of dividing by the square root of 2 is going to be multiplying by the square root of 2 on the top and on the bottom, okay? So if I take 16 times the square root of 2, I have to leave it like that. Now in the bottom, I have the square root of 2 times the square root of 2, which 2 times 2 gives me 4. 4 is one of our perfect squares. The square root of 4 is 2. This is an equal sign. So we actually get a 2 down here in the bottom. Now, this is our answer here for the leg, but we can simplify this. You can take 16 divided by 2 and get 8, okay? What you can't do after that is anything with the square root of 2. So 16 divided by 2 is 8. Multiply that by the square root of 2 that was already there, and that's the answer for your 2 legs. So this one's already done because x and y are congruent legs. All right, 45, 45, 90 triangles have congruent legs, okay? So our 30, 60, 90 is a little bit trickier, okay, but the same principle is going to apply. Now we are given, it looks like the longer leg in this question. It's across from the 60-degree angle. So we need to find the shorter leg and we need to find the hypotenuse, okay? So what we have here, the only information we're given is this side of the longer leg is 42. Well, the longer leg is equivalent to x times the square root of 3. So I'm going to set that equal to the 42 that they give me. And again, I'm solving for this x, not this x, okay? So I'm going to do the same thing I did in the last problem, and I'm going to get that x by itself. Okay, so I'm going to divide both sides by the square root of 3. 42 divided by the square root of 3 leaves me with a radical in the bottom, and I can't have that there. So I'm going to do multiplication to get rid of it on the top and the bottom. Okay, so down here, square root of 3 times the square root of 3 gives me the square root of 9. The square root of 9 is one of our perfect squares. So if I look here, the square root of 9 is 3. So what I have is on the top, I have 42 times the square root of 3, and on the bottom, I have 3. Okay, let's see if we can simplify this like we did over here, 16 divided by 2. Can we do 42 divided by 3? Yes, we can. We get 14. So this is, I'm going to use this space over here. This is 14 times the square root of 3. Now what we just solved for was x, okay? So x in our 30, 60, 90 triangle, x is the shorter leg. It's across from the 30-degree angle. So we solved for this guy right here, all right? 14 times the square root of 3. Circle those so you can see them a little better. Okay. All right, so we've got half of what we need. Now we need to find y, which is our hypotenuse. So our hypotenuse is 2 times the shorter leg. Okay, 2 times x. X is the shorter leg. Well, we know the shorter leg to now be 14 times the square root of 3. So what's 14 times the square root of 3 times 2? Okay, well, the 2 would be outside of this square root, so I can't do 2 times 3, but I can do 2 times 14, which is 28. So our hypotenuse is 28 times the square root of 3. Okay, and these are our special right triangle problems. So again, if you need to pause, rewind, look at a problem again, this video will stay posted, so you can do that however many times you need to. And I'm going to go to the last topic, which is our sine, cosine, and tangent. So for sine, cosine, and tangent, this is where we're going to be coming up with trigonometry ratios and solving for a missing side. So for sine, cosine, and tangent, all you need to remember is SOHCAHTOA. Okay? So this will tell you what to do with sine, cosine, or tangent. And we have some other letters here that represent the O is opposite side, H is hypotenuse, A is adjacent, okay? So we're gonna give the ratios, and we're gonna write those ratios as a fraction in simplest form, but it looks like we are given an incomplete right triangle. We don't know what the hypotenuse is, so let's use the Pythagorean theorem to solve for that. A squared plus B squared equals C squared, okay? And if you want to double check the math on your calculator, you are more than welcome to. I'm just trying to speed it up a little bit by just writing down the sum for you. Square root of 1,156 is 34. So our hypotenuse is 34. Okay. Now we want to know what the sine of Q is. So it's always going to refer to a certain angle in your right triangle. So if we look over here, angle Q is right here. Okay, sine would be the opposite side over the hypotenuse. So opposite means across from, which is 30, over our hypotenuse, which is 34. Okay, and in your homework that you did before Christmas break, I always had you simplify your ratio, which in this case would be 15 over 17. All right, next one is cosine of angle Q. Cosine is the adjacent side over the hypotenuse. So adjacent means next to. This side is next to angle Q, so it's 16 over the hypotenuse, which is 34. And that simplifies to 8 over 17. Last one's tangent. So opposite side over adjacent side of angle Q. Opposite is 30. Adjacent side is 16 because it's immediately next to angle Q. So we're going to do 30 over 16, which simplifies to 15 over 8. Now the last three we're going to look at is sine. Okay, so the sine of r, the cosine of r, the tangent of r. So angle r is right here. Get that out of here. All right, sine, opposite over hypotenuse. The opposite of angle r is 16. The hypotenuse is 34. Which again simplifies to 8 over 17. Cosine is adjacent over hypotenuse. So adjacent, immediately next to, over the hypotenuse. So 30 over 34, which again, 15 over 17. Last one is tangent, opposite over adjacent. So the opposite of angle r over the adjacent to angle r. So 16 over 30, which simplifies to 8 over 15. Okay, so now what we're going to do is we are going to solve for x. Round your answer to the nearest tenth. So you need to grab a calculator, whether you're using your cell phone or a regular graphing calculator. You want to make sure that the mode for these types of problems is in degrees. Okay, which mine already is, but if it's in radians, you want to change it to degrees because we are using degrees in our problem. Okay, so calculators need to be ready. And we're going to use the angle they give us to set up a trigonometry ratio. Okay, so what they give us is the opposite side and the adjacent side. So to the angle they give us, which is 54, we have the adjacent and the opposite. So we're going to use the trig function tangent because it has the O and the A. Okay, so for tangent, we're going to take the tangent of the angle they give us. See how in these problems it said angle Q or angle R? Now we actually have a degree measure to work with. So we are going to take the tangent of 54, and the tangent is equal to opposite over adjacent, which is x over 9. Now, since we're solving for x, just like in algebra, you want to get that letter all by itself. So how do we get rid of a divide by 9? Well, we multiply by 9 on both sides. Okay, so I'm going to do 9 times the tangent of 54 degrees. So your tang button is right here, 54, close parentheses, press equals, and I'm going to multiply that by 9. If I round to the nearest tenth, that would be 12.4. Okay, and that is the answer for x. So I'm going to move on to the next one, see what they give us. Our angle in question is 46 degrees, and we are given the opposite side, and this is the hypotenuse because it's across from the right angle. So which trig function has the opposite and hypotenuse? That's going to be sine. So the sine of 46 is opposite over hypotenuse. So we're going to take 24 over x. Okay, how do I solve for x? Well, I want to take that 24, get it away from the x. I'm going to multiply it by 46. Oh, sorry, divide by. Okay, because right now I'm doing 24 divided by x. All right, so I'm going to take, let's see, get x by itself. Okay, I'm going to get x by itself by doing 24 divided by the sine of 46. Okay, so let's do sine of 46. Okay, and then I'm going to do 24 divided by the answer I just got, which is that 0.71933. And if I round this to the nearest tenth, I'm going to get 33.4. All right, now let's do one more so that we can do our cosine function. All right, which is going to be my question 30 up here. The angle in question is 35, and we are given the hypotenuse because it's across from the right angle, and the adjacent side. Okay, which means we're going to use cosine, adjacent, and hypotenuse. Okay, so the tangent, the cosine, so the wrong function there. The cosine of our angle they give us, which is 35, equals the adjacent side, which is x, over the hypotenuse, which is 21. Okay, so we're going to multiply both sides by 21. Sorry, my phone keeps refocusing. So what we're going to do is 21 times the cosine of 35 and see what we get. All right, cosine 35, close parentheses. Gives me a decimal. I'm going to multiply that by 21. And that gives me a rounded answer of 17.2. Okay, we're finally done with our trig review. All right, these are all the types of problems that we had in our trig unit, and this is going to wrap it up for us. We'll start a new unit next Monday, whether we're in person or not. So make sure you have all of these copied down. I'm going to keep track of which ones you should have done for your notes, and I will post the homework problems as a separate picture in Google Classroom.